Good evening, everyone. How are we all doing? Just doing the usual checks, making sure the volumes are good. Okay, yeah, I think we're good. So, welcome to the Sunday night stream. I'll be working on more of the Galaxy stuff tonight. I've got a couple of issues I need to fix and just generally polish what's already there. Big news this week, as you can probably see here, that is a database with 2,000 light years worth of real-world stars, and that is 17,600,000 and something real-world stars, which is a lot. Right now the database is about 2.5 gig, and with some optimizations, converting a few floats to integers, we can probably bring that down to about 1.5 gigs. So that's pretty good. It's taking around about 20 milliseconds to do a query, which isn't bad at all really, and that is per sector, so that's 20 odd milliseconds 27 times for our 3x3x3 cube. Yes, moons will definitely be added soon. A lot of the stuff I'm doing right now is the groundwork for moons and other satellites like space stations and things. That's very much all part of this. We don't need player systems, we just need lots of star systems. So in order to incorporate the real world data, I have changed a couple of things with our Galaxy Gen. Just a quick question from Paul there. This has probably been answered elsewhere, but when will the captain level funders have access to the star system creation? Hopefully soon. There are two components to that. One is an actual in-game tool for creating star systems. Now, half of that's there already because it's what I use. So I just need to expose that, with a UI and have some way where you can actually create and save star systems. The other part of that is we need to be able to store and manage that data on our website. And we're still looking for either someone we can take on full time or a company we can work with to build that site and build all the actual back-end functionality we need for that. So soon, we'll see the in-game version first, and you'll at least be able to create a star system and have it locally in your game. For that star system to be there for everybody, obviously we need the website finished. So there's a few bits and pieces which need to kind of fall into place for that. But sooner rather than later. It's definitely one of the priority items on the list. Right then, so when we were previously generating our sectors, what I've been doing is I've been just capturing the coordinates and deciding whether or not that is a sector that should be special in some way, like the Sol sector or the Saj sector, sectors that have some manually placed things in them. Now obviously that's not at all expandable, especially not when we've got 33,000 sectors worth of real world data. So this function for generating the procedural sectors is now a one-size-fits-all, so this is no longer needed, and neither is that. So at some point this evening I will be deleting those. And that's no longer just procedural, that's also real-world data as well. And the way this now works, I don't know if anyone who has watched the previous streams remembers this, but this was quite a chunky blueprint. And what I've been doing is I've been really refining this down to its absolute basics to try and make it as small and as lightweight and as efficient as possible. So the way we are now doing this is we create our random streams as we did before. We work out whereabouts in the galaxy this sector is, and then what type of sector it should be accordingly. We then work out the density, so the stellar density, how many stars there should be depending on what region we're in. We then work out our basic sort of background political state. We then extract the real world data for the sector that we're in. So we take our sector ID and we make a string out of that, and that becomes our database query. And then we dump all that into an array. So now that we have our array of real world stars for that given sector, we also add to that the backer systems as well. So you can see with the backer systems that it's beginning to be added now. Obviously that's not hooked up yet because we haven't got a tool for creating them, but that's where they'll go. And then what we do is we add the number of real world stars, number of backer stars, and then we extract that from the procedural stars. So when we're generating the populations for, say, M-class procedural stars, we would deduct the number of real-world procedural stars first, so that we are essentially meeting this value. So we're backfilling missing data with procedural stars, so that the actual overall number of stars within a sector remains what it should be. And then once we've generated the procedural ones, we actually generate our stars properly. So all we do here is we go through the database, we drag out the Kelvin value, its coordinates, what it's called, run a couple of little helper functions on that to derive some stats and things, and then we add that to our data. So it's practically the same process that we were running before, only a lot more streamlined and even more step by step than it was before. But because we're doing it this way, and because we're taking our real world data and then backfilling procedurally, it means that this one function could fit every sector in the galaxy, and it will just take into account whether or not the data exists in the database, which is nice and straightforward. And then the last thing it does is generate the procedural stars in the gaps remaining. I've got some work to do with this because there are a couple of instances where, especially with the Sol sector, the procedural system doesn't really care where the existing stars are, so this could quite happily generate an A-class star right next to Sol. So I need to put some safeguards in there to stop that from happening. I might even prevent any procedural generation just in the Sol sector to stop that from happening. But we'll see. We'll see how that comes out once I start condensing this down and making it more streamlined like this. Magic sectors. Exactly. Anasi, yes. Well, I'm not wholly working alone anymore, because the actual database for the real world data, one of our backers has been working on that, so that's been really helpful. So Udai has been working on extracting the data from the Gaia database and Simbad and getting all the stellar data and putting all that together. So that's very much something I've left in hands to do all that. So that's something I'm not doing. And similarly, when it comes to setting up all these random streams, which again is a whole new system, then Tristian, again, one of our Fleet Admiral backers, I believe he's got a maths degree, and he's got a lot of skill with C++, so he's been putting together some things as well. So although no, we don't have any permanent staff on board yet, because hiring people is a lot more complicated than it would have you'd first think. It's not a straightforward process of just I want someone, here's some money, work for me. there's a lot more to it than that. But yeah, I'm no longer solely working on my own. But yeah, so what Tristan's been doing, he has created this random stream from vector function, and I think I might have mentioned this on the last stream, but he's been refining it over the past week. So we now have 2 to the power 256 unique seeds, and that's such a large number. I don't even know how many zeros that is. That's just mental. But yeah, that's a really, really, really big number. So we can easily have 1 seed per cubic light year for a long, long, long way outside of the Milky Way. We're probably talking other galaxies level of distances. Certainly enough to include the Magellanic Clouds and all that lot. So those 2 things, so the sector data that Udai's been working on and the seed system that Tristan's been working on, combining those things with the refinement of the actual code itself, this is really kind of finalizing the galactic generation in its entirety, which is nice. It's nice to get to the point where the system is really starting to get bedded in. Thank you, William. I'm guessing your wife said yes, so many thanks to your wife. Right, so what's next with this? I'm going to quickly run this because I've noticed an issue with, for some reason, the procedural stars don't seem to be generating as numerously as they should. We will see. I need to be at the point where the sector data on the GPS aligns with the long-range sensors. As you can see, I'll be doing a lot of profiling with this. So this yellow spam at the edge of the screen, that's per sector. So you can see that they're generating quite quickly. That's awesome, William. I don't think Claire's listening right now, so I can get away with saying best wife ever. Okay, so according to the GPS, and actually that's another point. So it's coming up as an inter-arm region where we currently are, because it's just scooted off. If I zoom, because we now have that technology, you can see that we've just snuck outside of the arm according to my 2D galaxy map, and that's because the location of Sol is now true to life, to using real world data from Gaia DR3. So that means that this galactic map needs to be adjusted slightly. Now this was I found a picture of a galaxy online, and I just kind of photoshopped it and made it kind of unique, but it's not true to life accurate. And I found one. Let's see if I still got it. Do I still have it? Yes, I do. Right, so I found this one, and apparently this one is using actual real-world data to generate the galactic shape. Obviously, it's an artistic rendition of the raw data, but this is generated using the Gaia data. So the galactic arms and everything are accurate. So what I'm going to do is clean this up, run a Gaussian blur or something on it just to give us our data points in terms of density of regions, and that should give us a much more accurate galactic disk, which is in line with Gaia data. So that should be good. We are forever on a quest to have the accurate galaxy as much as possible. Yeah, so because we're not in the right region, we're getting inter-arm numbers of stars, which is no good. That aside, it is also reading only M class for some reason, which is strange. Which means we have very little in the way of data on the map. Now, another issue, which you might immediately notice, is Alpha Centauri has been given a weird name, again because that's how it's coming out of Gaia and Simbad and the various data sets. So we're going to have to run some sanitization on this. I noticed there was a few others as well with weird names, like that one. That should be Epsilon Indy, and obviously it's been shortened. This is interesting. It's either an LT or Y class that's come out of the data. Obviously the game doesn't have the ability to do those yet, so I'll add that. For now it's just coming up as a really, really cold star. What else do we have? A couple of those. Any of them that come up red are going to be very, very cold stars. But the data is there, so that's the main thing. I should have fixed the filter now because I noticed it wasn't showing all of the stars straight away. So that should now be defaulting to show all. Notice that it's still misbehaving a little bit, so I'll have a go at fixing that in a minute. It's also not generating the right data. Sorting, yes. Obviously you can now filter, so if you want to just see M-class stars, you can do that here. In terms of sorting by class and have them all in the list, yes, if we can find some UI space for that, I don't see why not. I mean, we've got the data there. The sorting functions are quite heavy, depending on the amount of data, but if you're only using a small view distance, then that's not too bad. Right, so if we, because I thought this was interesting, if we go and just fly somewhere else, let's go a little bit further afield. So if we go to, say 26,500, cheat our way there. So you saw the lag then as that was generating the sectors. It's taking around about 100 milliseconds to generate a sector at the moment, which isn't terrible. You're only having to do that every 100 light years or so travelled, but it is something we'll refine over time. What I found is that certain areas have interesting sort of stellar densities, and you can start to see clusters and things that are coming from the Gaia data. Can't remember offhand where I saw an interesting one. Not that many. So here we've got a lot more in the way of procedural stars, so the generation time is taking longer. But it's only this long in the engine. When you're actually in a packaged game, it's nowhere near that long, which is good. It's probably predominantly procedural data, though we do have some Gaia data popping through. So the nice thing with backfilling this is that some sectors may only have a couple of dozen stars from the Gaia dataset, so it means we can maintain those populations with the procedural ones. I'll have to... I'm not quite sure what to do with the Gaia naming convention, because all the stars that are specifically from the Gaia dataset have got these awful names. So I might leave the name as part of the scan information. So we'll have the Gaia reference on here somewhere, and just call it, you know, like M-class star or K-class star, or whatever the sector name is, just so that we're not creating this awful list of numbers. I wanted to find one of the clusters that I stumbled across last time, because it was quite cool. Let's go there. GT. Interesting bug. Can't find it now. Space is too big. But yeah, as you fly around and explore, you'll see sort of interesting clusters of stars, which are from the data, which I thought was really cool. Places where, like, there's a star-forming region that's now, you know, present in the data. So I guess the test I need to do with this is I don't think I'm actually adding the real world star count to this list, so I need to make sure I do that. So I think what's probably happening here is there's enough real-world K-class stars to remove the need to procedurally generate any, so it's coming back with 0. So I'll just add those together. That's the thing we need to get consistent now. GPS needs to be consistent with the long range. Okay, so on here, and again, this is quite a brute force way of doing it, because what I don't want to do is run repeated queries on the database itself, because the database contains 33,000 or 36,000, I think, 36,000 tables, each one of those having, you know, a couple of thousand rows. So that can be quite heavy to query. So once we've generated an array for a sector, I want to only work off of that and not keep hitting the database. So hit the database once and then work off of the array from that point, which means rather than just doing an SQL query to say count any rows that match M class. We have to do it like this instead. So we're just taking our spectral type, seeing if it has an M in it for M class, and then counting accordingly as we loop through the array. It's quite brute force, it's quite straightforward, but it does the trick. And then, as I said on here, oh look, I discovered you could change the color of these. So yeah, I did my usual and class colored them. What can I say? I'm a bit of a magpie like that. But yeah, so we're removing the real world data from the final result. So when we are running data only, just working out the best way of doing this now. I think what we will do is go ahead and get rid of these bits that we don't actually need anymore. So that should not be needed. Just tidy this up a bit. Again, there's nothing I love more than deleting code. Right, so that's probably about as straightforward as we can make it. That's no longer a procedural sector, that is now just generate sector. Nice and simple. Okay, so if we're running data only, which is what we do when we are generating a single sector, so on here, and the same thing is true on here. We don't need this anymore. This is what the sectors call, so the sensors call when they're running. Right, so you just go in there, you just go in there, which means we don't need them. Right, and that cleans that up a bit. So we run a blueprint interface from the sensors, and that essentially runs this function which responds back with the data. Pretty sure it's only using this one as well, so that's probably not needed for this, but it can stay there for now. Right, so now we know that regardless of where we are, it's always going to be running this function, whether we're retrieving data or not. So when we do our final count, where are we doing it? It's the downside to having everything tidy. I kind of forget where things happen. Probably here, yes. So all these ones that aren't connected up to anything, this is the rare star types like wolf, white dwarfs, etc. They're kind of there as sort of ready to go when we add those star types in. So yeah, so this is where we're populating those. So I'm just thinking we don't need to be doing that there, and shouldn't be doing that there. So right, let's get rid of that. So really, none of these need to be counting their number quite yet. Simplifies all this. And, this macro I've made per class, I won't do it yet because it's a bit of a hassle to extract all this, but I'll explode that and just keep it all here on this collapsed graph. I think I did it for these ones. Yeah, so eventually they'll all look like this. Keeps all of the data generation all in one place, so we can see what we're doing at a glance. Yeah, it's one of the powers of doing it with blueprints, is you can see the flow nice and simply in front of you. Easier to debug. Get that there. That needs to go up there. That needs to go over there. Needs to say execute. Right. Okay, so we're no longer counting on there, which means that all of that can go as well. Okay. And they're still sat there ready for later. So we can kind of need a step here. Yeah, so we do our two populations, and then we'll do the count there. So we need another pin in there, which did I put in the right place? Yeah, good. Then we need that. Collapse this in a sec. Yeah. Forgot how to do that then. Right. So we need to do this for all of the different classes. So if we collapse them and we'll do that, count sector populations. Is now 10. That is now 11. Right, so this should be relatively straightforward. We just need to stick a sequence on there. So black holes, O, B, A, F, G, K, M. then all we do with this one is we go down to our local variables, of which there are many. Just realised the black hole one is a real equivalent, because I need to add the SAJ sector to that. So we add those two together. That in there. Actually, if we put this over here instead, we need to do that once, and then we can, yeah, do that. That makes more sense. There's our black holes. And we can just copy paste it many times. So O, B, A, F, G, K, and M. I don't know if it's my fat fingers or something with UE5 lately, but I always find that dragging things off, it never quite goes on the pin as reliably as it used to, if you're doing it like quickly. Right, so there's our basic structure. Now we just need to set these. So that one is class. M. And then the same thing here, so I'll just swap these to the right ones. Make sure I've got the right ones, so can't possibly have those ones different to the rest of them. Just wouldn't do. Alright, so black holes, real and proc, O class, real and proc, B class, real and proc, A, real and proc, F, real and proc, G, real and proc, K, real and proc, and M, real and proc. Right. So that at least should give us accurate populations now for the whole sector. Okay, so that's where we generate the stars, and that's where we generate the procedural stars. Let's just have a quick look. Make sure that we've got the right kind of numbers. Addressec, yes. The view counts on the stars are off at the moment, and that's what I'm just trying to get to the bottom of. So technically, this is the Sol sector, Sol location. So Sol used to be at minus 25,800, 0, I think I had it at. This is now accurate to what the data is in Gaia/Simbad. So we are actually 55.8 light years above the galactic plane, which is 17.1 parsecs, which is kind of like the average value given depending on who you ask. As with most things with astrophysics, many different papers give many different answers as to what the actual real value should be. 17.1 parsecs tends to be the ballpark figure, so that's what we're going with. Yeah, 2.5 Han Solos. And again, yeah, that's the distance from Sag according to the data on Gaia. So that is saying 986 objects. Obviously there shouldn't be any black holes, so again, depending on sector, we need to be able to block certain things from being generated. Pretty sure we should have a B-class star. So that's giving us 986. Again, it would be higher, except it's coming up as an interarm region, which is purely because the 2D map is now not lining up with the real world data. So 2D map needs improving. So we should have more than 986 on our long range scan. So if we increase the range, I think it's something to do with the M class, because we're only seeing 88 within our 50 light years, and there's 722 just within that sector alone. So you'd think within 50 light years we should have more than 88. So I will look at what's happening there. I imagine they're being culled somewhere on the optimization. And we're only seeing 447 across the whole of the 150 light year space. So again, we're seeing less stars than there is even M-class stars across the whole galactic space there. So something isn't right with that. The question is what? Just making sure that it's definitely generating properly. So here's a kind of difference, like within the spiral arm region itself, you've got a hell of a lot more objects. Stefan, I'm not sure what you mean by skipped generation process. The only times we skip generation is if there are already enough real-world stars to fill a sector, so we don't need any procedural ones to backfill. I suppose the easiest way to work out where we're losing stars is to kind of capture right, yes. So this one here, this is for the backer systems, which we don't have yet. So we're not doing anything with that yet. Yeah, these ones are all okay. Yeah, so that's what that is. And also, when we start making our sort of handcrafted alien empires, they'll come under this one as well. So we'll probably have 3 databases. We've got our real world stellar data database. We'll also have actually a real world exoplanet database. So that'll be 4 databases. We'll have the backer systems as a separate database, and our manually handcrafted alien empires database. So those are the 4 data sets that will be read by the game. So because we know how many we have here, and if we look at the event graph, so some of this is happening async, which is why these nodes are all over the place. Sadly, I can't do the Galaxy Gen async because of the reading of the texture file. Because we're reading that, it breaks the asynchronous generation, which is annoying. So I need to find a way of doing an async texture query, and that will speed that up. Three types of star at the bottom. Do you mean these ones? So Wolf Riot stars are massively bright young stars that are still forming. I believe Wolf Riot stars are like the initial star formation. Giant stars are the likes of Betelgeuse, so either main sequence stars that are in their final death throes, or just giant stars. I forget off the top of my head what T Tauri stars are. What is a T Tauri star? T Tauri stars are a class of variable star that are less than about 10 million years old. This class is named after the prototype, T Tauri, a young star in the Taurus star-forming region. They are found near molecular clouds and identified by their optical variability and strong chromospheric lines. So I would say they're very much in the same ballpark as a Wolf Riot then. What's it say about them? Wolf Riot stars, often abbreviated as WR stars, are a rare heterogeneous set of stars with unusual spectra showing prominent broad emission lines of ionized helium and highly ionized nitrogen or carbon. Okay, yeah. Wolf Riot stars represent a final burst of activity before a huge star begins to die. These stars, which are about 20 times more massive than... and the text is cut off, so I can't read it. But yeah, that's what they are. And we don't have those in the game yet, but we will do at some point. In fact, some of the stars in the real world data probably fit those classes, and they're currently being misrendered as main sequence stars, but we'll go through and sanitize that over time. Technically, the sun is a green star. Its strongest spectral line is in the green frequency. Obviously it's white because it's a fairly balanced spectrum, but out of that balanced spectrum, at least last I knew, green is the strongest of the bunch, which technically makes the star green. So before we go and do our sorting, I need to be careful here because some of this is happening as an async background task and certain things don't like working, like print screens, for example. Is it going to mess it up? So yeah, let's do it in here. So if we get the length of that array, pre-sort, borrow that a minute. Let's make this a different color. Let's give it a nice orangey color. Yeah, I mean, using the game as a teaching tool is very much one of our objectives. So I think there's a wealth of knowledge there, certainly in terms of, I'd say, basic astronomy and basic astrophysics. Just little things, if nothing else, like the structure of a galaxy and what the different regions of the galaxy are. Like learning the difference between the thin disk, the thick disk, the halo, open clusters versus globular clusters. These principles and types of information, I think are valuable, and it's valuable knowledge. Well, there's our issue. We've gone from 16,000 stars down to 400 and something. Try a couple of other sectors. Yeah, so the spectral lines of a star tend to be fairly consistent between main sequence classes, depending on their Kelvin temperature. If we split the Kelvin range into set ranges, which I have actually already done. Hang on a sec. That reminds me of something that I did earlier. Hang on, let me just find it, because there are far too many channels on our Discord. So I put this together. Excuse your eyeballs, sorry. So obviously each class of star has 10 subclasses, and more than that because you've got like 0.5 on some of these as well. So what I've done is I've taken the published midpoints of various Kelvin values, and then I've created ranges from that all the way through the spectral range, and sort of run that against known stars to try and match. And if you look at the values here, the ranges I've come up with, are pretty much spot on. This is just based on what it says on Wikipedia for these stars, so take these with a pinch of salt, but it does seem to be calculating the sub-ranges fairly accurately. So if we've got from O class down to M class, and there are 10 subclasses, then that gives you a total of 70. So we need 70 different PNGs, with each of those PNGs showing the spectral readout for that temperature range. So yes is the answer to the question. Yes, we will have a gradient picture of the spectral range of the star, and there will be 70 different ones depending on what spectral range the star falls in. They will be static PNGs because that's a lot to try and do on the fly, but I think for the purposes of the game, that's sufficient. Change our location a sec. So it's 25,800. Let's go for 25,500. Cheat our way over. Rather randomly popped us straight into the nebula, which is cool. Okay, so we went from 55,000 stars down to 1,700. So our sort and filter is obviously broken, so I need to go and fix that. I really need to do something about these Gaia names because they're crazy. Just taking a moment to appreciate the nebula. Wondering whether that blue bit there might be the edge of an open cluster, kind of merged with this one. It's interesting. So we know that the problem is here. Now I happened to do what I thought was improving this. So my efforts in improving it might just have broke it at the same time, which would be typical. So just to step through this macro and what it actually does, we start off with an unfiltered list of sector locations. So that's every star system within the 3x3x3 grid. So you can see it was like 55,000 stars at one point there before we filter it. So the very, very first thing we need to do is remove a whole chunk of those stars which are out of range. So things like the M-class stars, we really don't want to be generating those 150 light years away because they're so dim and so far out that you wouldn't be able to see them anyway. So having them in the data, especially when you consider like 76% of the data is M-class stars. Cutting them out soon is definitely the way forward. I think we'll increase the range of the G-class a little bit there. So this is essentially, how far away can something be before we cull it from the data, because we then have to run a sort function on this data, and we don't want to be running a sort function on 55,000 array entries. Certainly not once every 1 light year, which is how this works. I'm going to make a few changes to this. So O-class stars should be visible from a long way away. So we'll just give that a crazy value. Similar for B-class stars. I mean, they're huge and bright. Same for A-class as well. Essentially, we don't want to cull those. So if they're in the data, we keep them in the data. I will leave these ones as is for now. What I will do is I need to go through the real world constellations, work out which stars are in each constellation, and then work out what type they are and whether or not they need to be visible and how far away they are. And I kind of start driving this from that for now. What we want to do long term is we want to do this based on relative magnitude, so apparent magnitude. So for each star in the data, we'll take that apparent magnitude value and cull them based on that. So if their apparent magnitude goes below a certain threshold, they're too dim to see and they can be gone from the data. And that will rule out most of these M-class stars anyway. It's a much more correct way of doing it than just having a table like this. See, black holes are an interesting one. I've left them at the top end of the scale because they may not be very bright, but they're certainly very energetic, high emission objects. So the sensors could probably pick them up from quite far away. Yes, Betelgeuse will go supernova in the game. It's something I've got planned for the first expansion. So when we do the actual proper story mode, one of the missions in the story mode will be to go and perform science on Betelgeuse going supernova. So you'll get to see that up close and personal, real time as it happens. We just need an art team involved to actually create the effects for that, because obviously that's going to be quite visually stunning. But on that note, we also want other supernova around the galactic space. So we'll have it so at a very, very, very low percentage, there will be stars that will basically be ready to go supernova, and they're like, hold it until you get nearby, and they'll be like, right, there's the player, boom, and then they'll go supernova. So they're just kind of, keep their legs crossed until you get near them. Firstus, yes. So this function is fired every 1 light year. So every time the ship moves into the next grid location, because the galaxy has a grid resolution of 1 light year. So every 1 light year grid resolution, it resorts the data to work out which stars are closest to your current grid reference. So knowing that, we can then use that to work out their apparent magnitude and thus whether or not they should be visible. So as you're flying along at warp and you're going from galactic grid point to galactic grid point, the stars in the sky will be getting brighter and dimmer, depending on where you are. We just need this to be as rapid as possible, and that's something else that Tristian's working on, actually. I'm not sure it's quite completely within his skill set, but he's certainly having a go at it. So it'll be interesting to see what he's able to achieve with that. And we can run this async, and we can sort the struct directly without having to break it out into a separate float array. The whole thing gets quicker. If we can get this real-time levels of quickness, that kind of makes the ship speed infinite in terms of its capabilities. So right now the speed of the ship is kind of limited by how quickly we can generate the data. So we need to get to the point where we can generate data a lot quicker, which means upgrades for the ship can be more effective. Right, anyhow. So I'm wondering whether or not I stopped setting this variable, which means this distance measurement becomes irrelevant. So all we're doing is we've got a local float which we're assigning a value to once per loop entry, and then we're running our boolean against that, and then we're also using that same value for the distance in the array. So we have a separate array. So we start off with the unsorted list of 55,000 odd, and then we make a separate array, only the stars that are within the acceptable range. So this is the array that we then sort, but we can't sort the struct directly. So we have a side-by-side array of floats, which is these distances, with a corresponding index. So the array index is the same for both of these. So we know that as we're sorting this, we can sort out this as well at the same time. Again, it might not be the most efficient way of doing it, but it's what works at the moment. And what I was doing is removing the bad data from this array. But again, because this array has got 55,000 lines of stuff, every time you touch it, there's a cost involved. So we touch it once to do this, and then we only work off a copy of the data. So we don't keep hitting that 55,000 monolith of an array. So yeah, so my best guess as to why this is broken is not the new stuff I added here, which I think gives us an efficiency improvement. It's probably we're not setting this properly. But where are we setting it? That is the question. So we set it there, right? So that sets the ship's location in space. And then we set it when we do the load data. So they should be fairly static. Yeah, it could be something like that. So if this is good here, then either the location type isn't being set properly, which means it could be coming up with a 0, or the coordinates themselves aren't right. I would run some blueprints of this, but it's going to be a lot of rows to try and manage. Right, let's have a look at the generation code again. It's one of those things where I've done a lot of improvements on this and a lot of refinement, and I haven't noticed the problem, so I don't know exactly at what point it went wrong. I wonder if because the pure procedural sectors don't tend to be too bad. They seem to have a lot of data. In fact, we should check that. Yeah, as far as backer's concerned, it's already released. That aside, yes, the public demo is the current polished version, and that will be updated soon. The whole concept of a release date for this game is kind of irrelevant, because we're updating the demo as we go, and we're putting out 2 builds a week for backers. So, yeah, so the idea of a release date, in air quotes, is kind of irrelevant, because it's already out, it's already there. You can already play it. It's just obviously unfinished. So I suppose the better question would be when finished, and I'd say you're looking at 1 year minimum for the basic feature set. Garzini, yeah, something like that, definitely, because we obviously want to be generating the really massive stars from a long way away, and in some cases we need to be doing that for things like the known constellations, because some of the stars in our known constellations are many hundreds of light years away, if not thousands in some cases. So when it comes to the biggest, brightest stars, we need to be generating that sector data, but it does mean trawling through those sectors, because if you think about, well, our current radius of 2,000 light years, 2,000 light years is 36,000 sectors. So that's 36,000 times you have to check for data, and that's a huge amount of stuff. Even if you're only drawing 1 or 2 stars at the end of the day, you still have to check first. So the question becomes, how quickly can we do that to generate those kind of ranges? I mean, it's possible. It's definitely possible. We just need to find the most efficient way of doing it. Right, so if we go where we know there is no real world data, so let's go minus 20,000. So we know the real world data only extends 2,000 light years, so this is outside of that range. So we should only have procedural stars, and immediately I'm not seeing very many. Is it because I've put us in a stupid place? It's like A Quiet Place, but stupider. Right, I think we will go... Let's reduce it by another 1,000. 5,000. Feels like a lot more stars. Okay, so we went from 62,000 to 2,700 odd. Which sounds a bit more like it, although perhaps still not quite enough, but that's... there's a lot of stars out there, so that's what we'd expect. And I've got my fake stars turned off, so those are all the real generated stars. Yeah, there will be different FTL speeds. Right now, the top speed is 300 light years an hour, which is kind of as fast as you want to go before the data generation can no longer keep up. I noticed that this didn't update to represent where the ship is, so I'll need to look at that as well. Right, so we're showing 5,000 objects within the sector. We've got, so most of those are M-class stars, so we're cutting them off at 25 light years anyway. So we won't see the full 5,000. However, we should see a chunk of that here. Yeah, that's more like it. So the outer edges of the scan range, this is all the A class and the B class stars there. And then you've just got that 25 light year range of M class in the middle. So I would say that that's okay. And then we've got just A class there. Far reaches of the scan range. Right, okay. So that would suggest then that it's actually the real world stars which are not generating as numerously as they should. Okay, so it's probably going to be useful to know actually just how many hits we're getting in the results there, because that could be a factor. So it could be this which is at fault. Let's just try ignoring this sort for a minute. This filter rather. This might result in a massive chunk of data, but we'll see. Planetary landings. So the current patch I'm working on is going to be a short range scans identifying life on planetary surfaces. The patch after that is going to be sublight flight, including things like colliding with planets and wormholes and general things like moons and asteroids, sort of things that are small enough that you need sublight engines to navigate around them. And at the same time, that will be HOTAS support, control remappings, essentially all of the flight model stuff. The update after that, I'll be predominantly focusing on the bridge gameplay with NPCs. So we'll get our first bridge NPCs, the ability to issue commands to them and have them actually fly the ship for you, that sort of thing. I think planetary landings might be something I look at after that one. So we're looking at probably about 3 patches down the line. But we'll see how the priorities change over time. Things might crop up that need addressing, that sort of thing. Okay, so again we've gone from 21,000 down to 609. Definitely still not enough. Yeah, so development builds, I'm now doing 2 per week. So every stream will be followed by a development build, which is essentially everything I've been working on in the stream plus a couple of days beforehand. In terms of the overall patch cycle, we're aiming to do 1 major update per quarter. 3 months to work on a major system is pushing it in some cases. Generally speaking, that's kind of what we're looking at though. So obviously during a patch cycle, so let's say that patch cycle lasts for 3 months, we will be putting out 2 builds a week during those 3 months. So at the end of those 3 months, that should be the finished, polished version of that patch. Some patch cycles won't take that long. We'll be able to knock it out quite quickly. Others may take longer, depending on what it is. Galaxy stuff generally takes longer because there's a lot more fiddling involved. But yeah, so I say ballpark, we're looking at 4 major updates per year. Proxima Centauri is kind of amalgamated with Alpha Centauri. They're all kind of in the same place. It should be a trinary system. Garzini, that might work, yes, because it relies on the mouse pointer location when you do the click. So yeah, if you hold E and touch the screen, it should work. I don't have a touch screen, so I can't test it. Theoretically, that should work, though. Right, so what I will do here. So we know how many stars we have because we're counting them. Although, let's do it here instead. So, yeah. So this should give us our full list of real-world stars per sector. Right, so you are stars. Again, that's per sector, so they need to be added together. But I think, see, this number should be a lot bigger than I think we're getting at the end. So, when we're actually adding that at the end, I don't think we're getting a true picture of the actual data. I guess the question is, which ones are we missing? And is the coordinate correct? The development builds are for captain level supporters or above. It's one of the backer perks. Let's just see what numbers that comes up with a sec. So this should give us 27 different counts of data per sector. And we can potentially compare that against the actual row counts on the database as well. So those 750s above, that's when the sensors are generating data. It's interesting. Let's have a look at that. Okay, so yeah, so the pre-sort number looks bang on. There's a lot of stars there per sector, as is expected. So, why is... Oh, okay, so I suppose... Yeah, so if I compare the number of stars we actually added to the data, so where are we? Here. So we know how many are in the data. So I guess we need to know how many did we actually add at the end of the day. So we're adding all of those to our sector locations array. Which is going to include the ones from the previous sector as well. So that means we need a temporary array, which I shall add here. Temp location array. And that is of type struct sector location. And then we shall add to that. Oh. Didn't make it an array. Yeah, so we'll build all that up, and then we will, same as we did here. So the stars are generated before the sort. So what happens is we, for each of these 27 sectors, which is our 3x3x3 grid, we run this function for each of those, and we continue to add those arrays together. So each one of these spits out its sector locations, add them all together, and then the end of this, which is here. So that's all of that happening. What we then do is we drop down here, and this is where we then run the sort. So this is that appended array that we've created up here. Then we sort it, and what we end up with is a filtered and sorted array with the bulk of that data removed, so that can then be used by the game. So it's definitely happening in the right order. I think though that something is happening with the actual stellar data. Let's get rid of them because I don't need it anymore, which means that can go away. A slightly different color. So this array count should equal this array count. They should be the same. If they're not the same, then something's broke here. And just for good measure, I will clear that array up here. Shouldn't need to clear local variables because they should start off clear, but I like to clear them just in case. I don't trust that they will be clear otherwise. The other thing we need to do, I noticed, is so we're running a branch here to stop it from generating procedural sectors if we're going data only, and we need to do the same here as well. So we shouldn't be actually generating them if we're running data only mode. And data only just means that it's just the sensors looking at the data, so we don't actually need to generate the stars. We just need to know how many there are. So we count that, count that, count that. Don't generate them, don't generate them, because we're just sending back data. That should stop all those 750s popping up that shouldn't have been there. Yeah, you're right. I haven't bought any new computer parts yet, and that's solely down to the fact I've been so busy working, I just haven't had the time. I will get around to it though. Although that said, I mean, I am already running off of an SSD, so this loading speed is just running in the engine. Packaged, it runs instantly. Realize what I've done. So I've stuck that at the end there. Of course it shouldn't go at the end there, should it? It should go down here somewhere. Here. I'm always doing that. I'll continue a bit of code off of the loop on a for each loop, and I always forget to stick it on the completed pin. So when I'm packaging the game, I've got an Intel Optane sort of plug-in SSD, which I think is just a PCI Express NVMe drive in a plastic box. That was kindly donated to us a couple of years back on a previous project. But yeah, I mean, so that speeds up packaging quite considerably. I can package the debug mode in about 1.5 minutes, which is pretty quick. The shipping mode takes about 4.5 minutes to package. But loading times just seem to be an engine thing. Okay, so we can see there that we're not skimming any stars from the data. All of these numbers match, which is what they should do. So that's good. So we know that that function is working fine. Oh, Claire just came in looking for the car key and it was in my pocket as always. I'm always doing that. She'll be like, "Where's the car key?" And it'll be in my pocket. Just get rid of some of this debug stuff because we know this is good. I think I'm going to leave the real world data being generated. Like, I'm not going to filter it at all. Yeah, because there's never a huge amount. It's not like we're getting like 3,000 M-class stars we've got to filter. So that can be fine as is. So if we know that the correct amount of stars are going into here, yeah, so Wednesday, I won't be here. I'm traveling, so there will be no stream on Wednesday, sorry. I have to skip that one this week. In fact, essentially as of tomorrow evening, I'm going to be off work for a week. And that'll be, I'm only off for like 4 days, but that's the first time I've had off in 3 years. So, yeah, I'm going to enjoy it. Just going through and making sure that, that all these line up. Thank you, I definitely will. We're clearing up our garden at the moment because I need to make some space for the future dev shed when we get that built. And our garden's a bit like a jungle, so we've got to skip in, and I've been out there with a chainsaw cutting things down. So we're going to spend a week just doing housework and getting this place shipshape. And then at some point I need to get someone in to put a concrete base down, and then we can get our dev shed built, which will be really, really cool. So I'll have an actual office then, rather than working out the corner of my bedroom like I do now. Right, so we're definitely adding to the sector locations array. Definitely. Wish it wouldn't open a new tab every time you click on one of these. But all of these ones should also be adding to, let's go for a numerous one. So these are also adding to the same array. Yeah, for sure. I mean, I've been working sometimes like 16-hour days for the past 3 years on this project, just non-stop. It's been my whole existence. So taking a week off is actually a bit weird. It's like, ugh, what am I going to do for the week? But I'm sure hacking away at bushes will keep me occupied. So we're definitely returning the right array as well. So this is a tricksy one, this is. Yeah, I think having passion behind the project really helps. I mean, I've been wanting to make this game literally since I was a teenager. You know, I'd be at school doing sketches in books and kind of working out that pseudo code, you know, imagining how I would build it. So to actually get to the point in my life where I'm now able to build the game of my dreams, yeah, that is a huge motivator. And you know, generally speaking, it's the last thing I think of when I go to sleep and the first thing I think of when I wake up, which some might call obsessive, but I've always got some idea on the go of, you know, how to do something or how some system should work. Okay, so this is where the wrong is happening. Right, so we have got an absolute butt ton of stars here at this point. We know that, there's a lot of them. We are then looping through said butt ton of stars and removing the ones that are not in the right range. So the only thing I can think of is that the galactic coordinates of the stars we're adding must be wrong. It's the only thing that would make sense. Right, okay, so I think to test this in a way that doesn't explode the game, like what I'll do is when we regenerate our sectors, rather than doing all of this lot, we will just do the one. So if we make an array, just pop that one in there. Right, so we're only generating a single sector, which is our current sector. So that's going to cut down 26 sectors worth of data. And then we will skip the cull on there. See what we end up with. So we should have a cube of stars, essentially. Good afternoon, Mike. Thanks for joining the stream. I always forget it's the afternoon in the US. It's just gone 10 PM here. So immediately there's more out the window. Nope, there are no multi-star systems yet. The data's there for them though, so it's a start. Okay, so what we see here, 986, which is odd because we've got 995 there, so we've lost a couple. We should also have 986 here. Here we have 993. Right, so there is our cube of stars. And that is essentially a full sector. And that's where Sol is in that sector. So we are 0 on the y-axis, and then close to the bottom because we're only 55 light years up. Yeah, it's like a Borg party cube. What's interesting is like the density of stellar data around Sol. Obviously that's because those are the stars that we've studied the most. Okay, so give or take a few stars, and I wonder why those numbers are slightly different. So that should be 995 instead of 993. So we've lost 2 stars there somehow. And like 10 there. Weird. So we're seeing 5 A class there and 5 there. So 24, 24, 50, 50. 1, 2, 3, and 1, 2, 3. 791 and 782. It's weird. Why is it miscounting the M class stars? Very odd. Must be a filter there causing some issue. But it's close enough, so I've just had a thought. So we are generating, or culling rather, the stars within 25 light years for the M class, 75 for G class, and so on. I'm just wondering whether the fact Sol is all the way down here might be playing a factor in Yeah, they could be. It seems to be around the M classes, but you're right, because like these bright red dots here, it's counting them as M classes, even though they're not. So that is probably where the difference comes from. because these are all LTY classes. So this is an example of why we need to limit the generation range, because we've got a couple of M-class stars here next to Barnard star where there wouldn't be, or there isn't, in the real world. So we need to make sure that we stop procedural stars from generating anywhere near known ones. Okay, so we know we've got 993 with an unfiltered list. So if we now filter that list, now obviously we're only going to get one corner of the sector with this, so that's going to be a lower number anyway. How much does it filter it down? That is the question. Yeah, that would be weird, Dave. I think if the filtered list has more stars, I'm just going to give up. Okay, we're safe. There's only 171. So that is as expected. Obviously we've got our M-class bunch there, and then they filter out across the other classes. So we've got 63 M-class, 5A, 22F. Filtered a couple of those. 32 Gs. It's filtered about half of those. $23, 48, 49. So, yeah. It might be that I'm chasing a problem that's not actually there. Unless we have it could be a dodgy sector in the data, maybe. So we could have a sector where the coordinates are off for that particular sector. That would cause this problem. Yeah, it could very well be cube versus sphere. let's push the numbers a bit. Definitely need to keep those M-class ones down though. Just thought actually that's not going to be helpful because I didn't connect it back up. So if we give it all of its data back, let's see. So we've got a bit more now. I think extending that range out has helped slightly. Definitely a bit more going on outside the window. So we're currently at 26,670. So if we go 100 light years at a time, take a look at the data there. Are we? Whoa! Surf the tablet. So we're definitely solidly into a spiral arm now. Still doesn't feel like enough. Because if we've got 2,000 stars in a single sector, which obviously is 37,000 across all the sectors, then we'd want more. Give me more. So I'll extend the filter range just a little bit, because we're in an ARM region, so there should be a higher density there anyway. Let's push them ranges out. I'll give this a try packaged later and see what kind of lag there is transitioning between sectors. Definitely a lot more in the way of stars. Again, I wouldn't expect to see any known constellations yet because we're only drawing stars out. Well, the maximum they'll be is about 150 light years. Because it's only one sector wide. Look at the data. Yes, now we're talking. It's interesting because you can see the shape of the data. It's like a Death Star. Funny thing with this actually is you can see how obviously the Gaia probe or Hipparcos, whichever dataset they're using, you can see that there's obviously gaps in the data. I'll have to work on the procedural backfill of that. It's interesting though. So if we just go full throttle, right, and if we aim the ship at Sag A, that means we're going to be transitioning towards a galactic arm, which means the density should go up accordingly. Yeah, that sort's not taking too long at all. That one slight hitch is once packaged, that'll be even less. Let's give it something to chew on. So if we go for 15,000, so that's going to put us kind of outside the galactic bulge. So this should be a significant chunk of stars. what's that? So we've got 12,000 stars out there now. Wow. It's a lot of stars. We're not even in the core yet either, so yeah, I thought that would lag a bit doing that. Right, so we really want to break in. Let's stick ourselves 1 light year above Sat J. This is probably going to hurt. Ironically, that's actually less stars, and the reason for that is because the galactic core is predominantly M-class, so obviously it's not drawing them as far out. Wow, that's a lot of black holes. Yes, so when you scan a star now, it's not instant. It actually does take time to scan. Yes, this is the kind of densities we're looking at in the galactic core. It's just crazy. What I like actually is that the galactic core region has a noticeable kind of golden glow to it because of all the M-class stars, whereas in the ARM regions it's a lot whiter because of all the higher temperature stars. So yeah, if we set that to 10,000 should be pretty much the top of the thick disk. Yeah, so like that was practically instant generation because there's nothing there. That's it. That's all you get. ZF, yeah, that's the sensor cutoff range. So that's not the generation of the stars. That's just how far the sensors can see, which is why it's a sphere. No, we're still going. We're still good. We go even higher with this, so if we go, let's go 50,000. So this will take us, right up into the galactic halo. No, there is nothing. 4 stars, apparently. So if we look on the GPS mode for that, I need to write a description for this. But you can see that in total there are 10 class stars in this cubic 100 light years. And we're vertically directly above Sat J. And obviously we can only see 4 of them because the cutoff range for M class stars is currently 50 light years. Now you can't see the galaxy as a physical object yet. You will be able to, so in the same way that we render the nebulas, we'll do the galaxy version of that as well. So as you fly up above the galaxy, you'll see it spiraling away below you. We just need a 3D artist to make a proper 3D volumetric galactic disk. Yeah, ironically, it doesn't actually need to be that big. It can be the same size as the nebula, but you move it more slowly, so it creates the illusion of distance. So if we go back to 26,500. Yeah, this is more of a typical region. That is a pleasing amount of stars. I wish I could find the cluster I found earlier. I'm not actually sure where it was. I was just scanning around the data and just stumbled across it. Perhaps it was further away, so 27,000. Ugh. Make sure I hide those while they're generating. Yeah, so the cool thing here is the space isn't as golden and glowy as it is in the galactic core, which is kind of cool. Ooh, is that a nebula far away in the distance? That's cool. So one other thing I want to just check actually. If we go to so it's 26,670. This is the new location of Sol. It's 56.9 years up. Right, this should take us to the Sol sector. They appear to be next to a star. Definitely nailed that one. what I want to see is whether or not the beginnings of any known constellations are just kind of appearing. So that's a good question, Mike. Yeah, one of our stretch goals on Kickstarter, in fact the top stretch goal, was if we made enough money, we would approach someone like Paramount or CBS or whoever makes Babylon 5, I'm not actually quite sure, and just ask for permission to create a ship as a DLC, but literally just as a DLC. Because what we don't want to do is we don't want to make it a Star Trek branded game. That's not what we're interested in. It would be awesome to include a vessel from Star Trek, like the Enterprise D or Voyager or something, just as a standalone DLC. So you can choose to explore the galaxy in that vessel. There'd be no story related to it. No characters from the show, nothing plot-wise. It's literally just the physical vessel, and I think that's the only thing we'd consider, because we have our own plans for the game. We have our own story we want to explore. So we're not interested in making it a Star Trek game, but including one of their ships, yeah, definitely. I'm not seeing anything in the way of constellations. It is fascinating how the stellar data creates these dense patches. Some of these stars are going to be part of a known constellation, but I think because we don't have the ones that are further away, we can't be exactly sure which ones they are. That's looking a bit like Orion's belt there, but also not entirely at the same time. Yeah, this is Sol, so if they're there, we'd see them. But nothing here is drawing further than about 150 light years away, so it kind of makes sense that we've been missing a lot. What I need, actually, I need to get a list of every star that makes up the major constellations, and make them like purple or something so we can see them. Just for testing, obviously. Yeah, Betelgeuse is the top left star of Orion. And Betelgeuse should actually be in the data now, so it will be in the game, except it will be in the game as an M-class star, not as a giant star, simply because of its Kelvin value. So, yes, Betelgeuse is there, but it's wrong. Right, okay, so I think the data's fine. I think the sort function is fine. I think everything is fine. It's just, it looked weird when it wasn't. Oh, thank you, Patrick. That's helpful. Yeah, because things like the Pleiades are too far away to be visible, because we're only generating a 3x3x3 grid. So my plan with that, by the way, is to start generating the outer grid sectors, but only generate like the O, B, and A class stars. So we'll start all the giant stars. So those sectors will literally only have a couple of stars being generated in their data, which should mean that generating them is rapid. The question is, how rapid can we make it? And the more rapid we can make it, the further out we can generate them. And once we've got apparent magnitude taken care of, then known constellations will start to emerge, because obviously those stars will be the brightest stars. Yeah, as Davesoft just said, Mike, it's yes, in the first story expansion, Betelgeuse exploding is going to be part of the story, but not until we get to that in the expansion. So it can sit there happily until then. Right then, so I'm just going to get rid of a bunch of this debug now. Because we know that's fine, so that can go away. Yeah, we could potentially have predefined galactic-wide signals. The trick is with most of it is that unless it's loaded in a sector, we don't know that it's there. So the game engine has no knowledge of anything that's not currently loaded as a sector. So if there's a sector, say 10,000 light years away with something interesting in it, until you get within range and the sector is generated, the game can't do anything with that. It doesn't know about it. So for those sorts of things, you'd have to have a separate list of things which need to be visible galactic wide. Can't remember which one of these now I was running debugs on. So no, it wasn't that one. Don't need any of that, and we don't need that. You used to be able to talk to Ava, Martin, using /Ava, and I had it hooked up to GPT 3.5. But I ran out of tokens, so that's disabled now. I don't think there's any other. Oh, you can use, if you do /console, and then you can use the Unreal Engine console. Most commands won't work in a packaged game, but I think all of the graphical ones do. So if you happen to know any Unreal Engine graphical console commands, then just do /console and then the usual console command and it should work. straight. There we go. Yeah, FTL comms is... I mean, there's been some debate as to whether or not we should have FTL comms, but if we do have FTL comms, and right now the thoughts that we are going to have it, it will be by way of micro wormholes. So originally we were going to use quantum entanglement, which is impossible, but we were going to hand wave it. But micro wormholes sound like they'll work better and are slightly more plausible. I missed a debug. Voice attack does already work with the game. So on the helm specifically, if you press F4, so all those helm key bindings at the bottom right, you can put those into voice attack and they do work. Ugh, debugs. Yeah, I think FTL comms is going to be necessary for gameplay reasons, and for when we do the story campaign. Having the ship completely out of contact with Earth it removes so many potential things that we could do with it. And like when we've got the GM tools, we want the GM to be able to hail the ship as an admiral, back at Earth, and give the ship commands and things to do, issue them with orders. And they need FTL comms to be able to do that. So yeah, I think there's more reasons to have it than there is to not have it. So I'm sort of 80-90% sure we will have FTL comms, just through necessity. Right, that gets rid of all of our debugs. Okay, so one last thing I wanted to look at is just switching the modes on the sensors, because I noticed some weirdness happening earlier. Okay, so seems to be working. So we've got 2,404, 2,405 there, oddly. Loving that zoom range. So this gap in the data here is because we're in the wrong sector type for Sol, and as such the amount of real world stars is more than the procedural stars wanted to create, which means it's not backfilling those. Once this is properly considered to be an ARM region, then there'll be more generation space and it will backfill these areas more completely, so you won't have these gaps. The sensor range is in layers, so the range for M-class stars is 50, and it increases outward as you go up the temperature range. So you can't see M-class stars all the way out over here, but you can see them here. And you can see here you've got the G-class stars, so you can see that slight subtle difference in colour, and then out here you've only got the bright ones. Okay, William, have a good one. I'm going to be heading off myself in a minute as well, so that's probably good timing. Thank you, Christopher. I still don't know where that Kofi bot came from. Right, so one last thing I need to do is I need to set the position of Sol. So when we start a new... I need to go back into the game actually. When I start a game, obviously the ship needs to be parked next to Earth. That's where we're starting. And I do not believe that it is now. No, Dave, you cannot. So the idea with the long-range sensors is that you'll be able to see that there are planets in the habitable zone, but whether they are an Earth-like specifically, you will not be able to see from beyond the 1 light year range. Once you're within that system, then you'll be able to see whether it's an Earth-like. Right, so where are we? So we're in the right spot. I don't see an Earth anywhere. Oh, okay, we are there. So what's happened is because we've used the new seed system, it means that the location of the planets on their orbital track has changed. So Earth has moved along its orbit from where it was originally. I think I'll probably set the start point of these manually so they're in the right place each time. But I need to move the ship over there and then capture the coordinates. Which means we need to find Earth. You know, I have a suspicion the labels aren't rendering. Interesting. Into that, it's behind me. Oh yeah, it'll be that blue dot there, I reckon. Okay, so another fun bug to work out. Why have we lost our labels? It's really hard without knowing how close I'm getting to it. That's no moon. Yes, first us, that would be very cool. Yeah, a monkey water world. I reckon this is as good a spot as any. Right, so I need to take a snapshot of that. Something you can do, by the way, Firstus, is if you've got access to the dev build currently, if you press H on the main menu, it turns into a screensaver. I shall demonstrate that in a moment. Right, so we need that. Here's one I prepared earlier. I believe that's the same amount of zeros on each one. Yeah, okay. Right, so that's 4, 6. I should have zoomed in on this. Would have been easier. 3, 4, 4, 9, 5, 6. And then that one is 6, 3, 5, 9, 4, 1, something, something, because it was blurring. I think 13. And the last one was 1, 2, 8, 4, 2, 8, 9, 7, 1, 8. I probably should have turned off the FTL. Right, so that should be our initial coordinate. So if we don't have a save game already, this is the default coordinates that it'll put us at. Oh, that's handy, Morris. Thank you. Where's Earth gone? There it is. Right, so we're in the right place, just need to do the rotation, but won't worry about that for now. So if we go to the main menu, so by default the main menu will just pan through what is an infinite array of procedural star systems. Why is it randomly doing a shader compile? But what you can do is if you press H, the menu goes away. And now all you're left with is literally just a screensaver of entirely random procedural worlds. It would be quite cool actually to make an actual screensaver. It doesn't do that random compile thing on a package game, so it's weird that it does it in Engine. Something else you might notice from this is I've actually set up the auto exposure properly, so on the brighter stars with brighter planets the stars are quite dim in the background, and on the really dark worlds the stars are much more brighter. Hopefully we'll see a dark world in a minute where that effect can be seen more, but that's definitely how I want to handle the star field in the game eventually, just to make it as realistic as possible. There you go, that's a darker one, you can see more stars there. But this is actually really lightweight because all it's doing, well, it's just a sphere with a light source. The heaviest thing will be the one with the atmospheres, but it's just generating the procedural textures. Yeah, it will be using your in-game settings. Yeah, I could just stare at that for hours. Yeah, so H, toggle the menu on and off to produce our awesome secret screensaver mode. It's got a ring. Anyway, we are now in the middle of nowhere. Okay, so I think that was the major things that I had to sort out on the stream. So all this is working now. So the next thing to do, I need to just sanitize this a bit more and optimize it like I have with these. I've already removed a lot of superfluous code, so they're literally down to this now. So it's very little going on. So little, in fact, it no longer needs to be a function. So I'll just explode the functions, collapse the nodes, and just tidy it up that way. So now that we have this, I'm just going to get my head around this now. So we've got the real world stellar data, which is generating. The sectors are backfilling where missing data exists, so that's working. We've got a largely infinite seed range, so that's good. So the next thing really is to build off of, where are we? Build off of the background state, and then start to actually generate life on planetary surfaces, which will take us into the short range scanning mode. So even though I'm taking a week off, I might work on a couple of things just for a laugh in my week off, because I do tend to do that. Hang on, let's focus on something inside the ship. There we go. For example, the sort of thing I would end up working on. I'm lost. It would be something like this, maybe. And maybe working on the functionality for something like that. Because I happen to really love pool. So I might make that a side project. But yes, I think that's pretty much what we're doing next. So the next step is going to be working on this. Where are we? This, the actual generation of sectors themselves. So again, we're obviously using a coordinate check to generate the manual systems, which is just not in any way expandable. That's just, you can only do so many of those before it gets silly. So I need to convert this data, so all of this, which is all the planetary data for each planet, all of that needs to be transferred into a data table, or probably even better, an external SQL database, SQLite database, so that we can generate the data without any real upper limit on how many we can have, and have it so that we are not doing these checks anymore. So like with the galaxy, where we just generate a sector, this will just become generate system, and then we don't need this anymore because it's all loaded in. If the data exists elsewhere, use that. If not, do it procedurally. Yeah, so I think that will be next on my list of to-dos. And then obviously this behemoth of a blueprint needs to be condensed right down, the same as this one, so it's all neat and tidy, and so that we're starting to generate life. So all these different planet variables and things, all of that needs to come together, and then we need to start generating our life calculations from that. That's the exciting stuff. I'm looking forward to doing that. And once that's done, that's pretty much all of the code that needed to be done for the demo update. And the only other thing that needs doing after that is just the front and the back of the ship, and at least in a basic way. Yeah, so I think we're on our final stretch now for the demo update, which is nice. Right, so on that note, it is now 11 PM. I need a cup of tea, and yeah, so as I said, no stream this Wednesday because I'm having a week off, kinda, and so the next stream will be on Sunday evening, a week from today. So I shall see you all then. Have a great week, and bye for now.